Hello and welcome. I'm Richard Okot. This week we our major assignment majorly involved geospatial analysis, and we use a geodata where majorly we were focusing on prediction of the heat difference, daytime heat difference and nighttime difference, and we were using linear regression. We also use decision tree classifier and support vector regression as a type of support vector machine. We developed 6 models, and out of these 6 models, we were able to select the best models, and under model performance comparison, for predicting the for predicting the daytime urban heat balance, we realized that the best performing model was support vector regressor, was best since it has the least mean absolute error, and the RMSE, the residual means square error, and it has also the highest R square of 0.98, implying the model was able to explain 98% of the variations. However, the decision tree also had a R squared of 0.97, that is 97%, and we will also consider it being also the second. We will consider it because it has a special feature importance which we can use to see to know which features are actually driving the high heat temperatures. And for the night, we also conducted the same, and out of the 3 models, support vector regressor performed better with a highest R square of 0.95, that it was able to explain 95% of the variations, while the decision tree classifier was able to explain the 88%. And as we noted, we'll also go with the 2 models so that we will utilize the feature importance in the decision tree to be able to actually know which features are driving these variations. So under the features importance, for the night, the feature importance analysis for the decision tree for the night UHI prediction revealed that the relative contribution of each features to the model prediction, the most important feature being buff and mean with the importance of 0.50, following by urban mean of 0.4%, and the population of 0.0123. And the same for the day, the most important feature was urban mean, or with an importance of 0.5752 followed by buffer mean of 0.90. So those features are what are important in deriving the the the, the temperature difference between urban and buffer. Mm, And we also are able to use plot the geospatial visualization that include the predicted urban heat intensity versus the comparison, and from the plot we can see there is similarity between the actual and the predicted, implying that our model was able to correctly predict those heat urban heat islands intensities the models were able to predict. And from our analysis and predictions, we are able to see that actually they are inconsistent with the geospatial presentation we see in the exploratory data analysis. And these analyses are important as they are of importance as they may be for as this analysis is important since it is a tool that may inform how the strategies, mitigating strategies can be addressed. And from them we can have targeted mitigation strategies, because from that we can be able to see which areas are experiencing heat, and we can develop a targeted strategy towards those areas with high heat. Another important use of the same that we can also be used to monitor and evaluate various interventions that are being implemented in terms of addressing high heat temperatures in the islands. And thank you.